If you are a systems engineer or related role in enterprise systems development with little to no knowledge of SysML or model-based systems engineering, then this course is designed to help you get started rapidly applying the language. It is an intensive course that goes deep enough into applying the language in many contexts and many application areas with many examples to practice with. SysML is a semantically rich language with high expressive power. While we commonly utilize language as representational or descriptive of real-world objects or abstractions in our domain, when the modeling approach becomes an integral part of your development methodology, it becomes so important to get accustomed to think of language, that's your model, as constitutive or declarative. You use it to declare things into existence. This example illustrates the usage of the containment association, which designates a parent requirement and one or more child requirements. Requirement containment allows complex requirements to be recursively broken down into more granular child requirements. The diagram illustrates the use of the copy dependency to allow a single regulatory requirement to be reused in several requirements hierarchies. The block definition diagram is used to define the features of a block and the relationships between blocks, such as composition, association, and generalization. In this reactor vessel example, the vessel references exactly one pressure sensor and exactly one pH sensor. These sensors are not constitutive parts of the reactor vessel, but they are structurally related to it. They are physically attached to it. A generalization is a taxonomic relationship between a general element and a specific one. Generalization is notated with a triangle symbol pointing from the specific element to the general one. Each instance of the specific element is also an instance of the general one. The example shows block on-off valve defining the features of any on-off valve, and two specific on-off valves, relief valve and reactant A feed, both specializing on-off valve. When the activity begins execution, a single control token is placed on the initial node and flows along the outgoing control flow. The rectangles attached to the activity frame are activity parameters. Value tokens are passed through input parameter nodes into the activity and through output parameter nodes out of the activity. In this example, action read reactant A amount will not begin execution until all of its input control flows and input object flows feeding its input pins have been received. A message can be a lifecycle message that creates a lifeline or destroys a lifeline. In this example, the monitoring station creates a new route instance. Notice how the head of its corresponding lifeline is not horizontally aligned with the rest of the lifelines, but begins at the creation point. In this example, A.receive occurs before B.send. Nothing is specified about the ordering of B.send and D.send or C.send and D.send. A state machine models the behavior of a block using discrete event-driven behaviors using a finite state machine based on an object-oriented variant of David Harrell's state charts formalism. A state machine diagram is a graph of state and pseudostate nodes and transition edges that connect the nodes. States specify allowable behaviors for the context block, while pseudostates represent junction points for transitions. This example models your registration for this course. It illustrates the usage of an orthogonal composite state which has multiple nested substates in concurrent regions. Starting with an unregistered state, once you register for the course, an operation called event in this case, your payment is processed and the state machine transitions to the registered state. Upon entry into that state, you are given access to the course content, the videos, transcripts, the practicum that runs through the course, access to the online forum, and the quizzes. The registered state is a composite state with one region containing the learning substate, which in turn is an orthogonal composite state with three concurrent regions. As you go through the course, you are watching chapter videos, taking quizzes, while at the same time interacting with others on the online forum. My name is Ernest Stambouli, founder of Achilles Inc., a training and consulting resource for digital engineering, specializing in the adoption of model-based systems engineering (MBSE). You can start learning SysML right away using our online training video course,